Good day, class. So this is a quick video on scientific notation. There's not a ton of math in Chemistry 100, but being able to read numbers is very useful, and scientific notation is a good way to start with that. Okay, so how this works is not super complicated. You have to be able to count to 10 and put a number above a 10. Okay, you're gonna be able to count in that. Count via base 10. It's a decimal system. When we say we have a decimal system, it means it's a base 10. All right. So let's take the population of the U.S., which I'm gonna guess is about 336 million. Okay, that's a relatively large number, and it takes up a lot of space. Usually, when you see this written in a published work, it says 336 million because they don't want to write that many zeros because it looks bad. All right, so scientists will frequently get numbers much bigger than this and much smaller. Okay, so to do this one, so we're going to pretend there's a decimal right here. There's not actually a decimal right there, and that matters for sig figs, but this class doesn't need sig figs. So we're gonna pretend decimals here, and then we're just gonna count. And we're gonna go 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. I don't usually put the commas on there. They're messing me up, man. So so I counted 8, right? So now we're gonna say 3.36 because we moved the decimal times 10 to the 8th. Okay? Since I moved left, the number above the 10 is positive. So this is what you do with any large number. Okay, so another large number. Let's clear the board here. I'm going to give you guys another large number and have you do it. I'm going to give you the number 54000000000. All right. Maybe pause the video. See if you can solve this. And I'm going to count down from 5, and then I'm going to do it. Okay, so we're going to pretend the decimals here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5.41 times 10 to the 11th. That's what you do with big numbers. Now we're going to do little numbers. Oh, sorry, laser. I meant to. Got this touchscreen, and the weird thing with the touchscreen is it won't work with any of my pens. But my finger works okay. I was using the mouse before when I taught mine. That was awful. I don't know if you guys have seen those videos. Those are bad. All right, now we're going to do a small number. So we're going to say 0.000. And the decimal's right here right now. Okay, that's very important where the decimal is located. 0.00000. Oh, this is 0, 3, 2. So before you move the decimal to the left. So we want the decimal to be right after the first integer. The integer is the non-zero number, okay? So this time we're going to move it to the right. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to write 3.2 times 10 to the negative 9. Okay? That's how you move scientific notation for a small number. This way, it shrinks down everything, and counting zeros. I don't know if you guys done that. It gets very tedious after a while. One of the most famous chemistry numbers is 6.022 times 10 to the 23rd. So if you want to right now, you could go and I should have you do problems that are back. I'll do that at the end. Okay. So now I'm gonna have you do one on your own. Okay. So we do the same thing as last time. So I'm gonna erase this. Maybe I can erase this. Maybe it'll erase. I want it gone. Clear all writing. Okay, now I'm going to give you your number to do. It's going to be 0.0000413. Okay, 5 seconds. Pause if you want to and try and solve it on your own. Okay, got the pause. So we're going to go 1, 2, 3, 4, 5, 6. 4.13 times 10 to the negative 6. That's how scientific notation works for small numbers. Okay, so we've done big numbers, we've done small numbers. Now I'm going to give you some scientific notation, and I want you to write the whole number out. Okay, so sorry guys, the way PowerPoint works, it just stopped me at the end of the slide because anyways. All right, so we're gonna have scientific. So I'll give you 3 of them. And I'm going to give you the scientific notation and see if you can write the number. Okay, so I'm going to give you 4.5 times 10 to the 5th. I'll give you 3.3 times 10 to the negative 4th. That's 3.3. And 6.022 times 10 to the 10th. I'm not doing 23rd on that. That's just too many numbers. Okay, so pause the video, try and solve these three, and then we're going to do it together. Okay, so this first one, we've got 5 there above the 10. So we're going to go 4, 5. So this is 1, 2, 3, 4, 5. The number, and then we're going to put so it's 450,000. Okay, so there's don't forget, when you times 10 to the 5th, move the decimal, the number counts just like a 0 when you're moving places. Okay, so the next one, 3.3 times 10 to the negative 4th. So we're going to put the 3 over here. So we're going to go 1, 2, 3, 4. So 0.000. 0.00033. Okay, and this last one is going to be a little bit harder because it's going to be 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal or comma, million, 100,000, million, billion, 60 billion, 220 million. Okay, so those are the numbers we got so far. Hope you guys have any questions on scientific notation. Please send me an email. I hope these examples help, and have a great day, guys.